All right, for the second type of graph that we're going to take a look at, the main difference that you're going to see on these today is here's the form. So a plus b cosine or sine theta. So now we have a value that's being added on, and so that's what's going to create the new graph. These are called limacins. So here's how it's pronounced, limacins. And limacins are broken down into three categories. And it has to do with whether A is bigger than B, equal to B, or less than B. And so we'll lay those out as we go through. We'll just start walking through a few of these guys. So on this one, you're going to notice that your A value is less than B. So anytime your A value is less than B, we get what you call a loop. In a loop, in the general, sort of the general sense, it's going to do something like this. And this is not a great drawing. You'll see a better one here in a second, hopefully. But it looks something like this. And so you're going to get a small radius, and you're going to get a large radius, right? And so a small and a large. And so that's the loop. So it goes something like this. If it's a positive cosine, it's going to be headed to the right, like this one is. A negative cosine would be going that way, positive sine, and negative sine. So that'll tell you the direction of it. As far as how big to draw these, we're looking at the sum of A and B and the difference of A and B. So their sum gives me the large radius, so this will have a large radius of 5. So let's just count that out. 1, 2, 3, 4, 5. So the large radius is going to go to there. Their difference gives you the small radius. And so their difference is 1. So my small radius will be at 1. All right, so there's my large and my small. As far as where else does this hit, we just need to look at the A value. So it's going to run through the origin, right? That'll be this guy right here. But it will also have to hit, in this case, because it's a cosine graph, it will cross the pi over 2 axis somewhere up here and somewhere down here. This is the value that tells you where that's going to hit. So I'm going to go from the center. If I go up 2 and I go down 2, that's where it's going to hit. So we have a pretty accurate sizing of this graph right here. And so we can just go ahead and draw it. We're going to look at where this thing sort of starts and ends in a later lesson. But with the cosine graph, it starts at the large radius. And I'll show you why that works in a later lesson. But it'll go something like this. So it's going to hit right there. We're going to create the small loop, hit the other intercept, and come back to this guy. So that'll be a really accurate drawing of the loop. You can also put your graphing calculator into polar mode and give that a graph and compare it to this, and you'll see how that looks the same. So that was the loop. So the loop is when your A value is less than your B value, and we're just talking as an absolute, right? We're not looking at the signs. If there's a negative thrown in, it doesn't matter. Like in this case right here, this guy is smaller than this guy. It doesn't matter about the negative. I'm just comparing 2 to 3. So this would also be a loop. Tell you what, while we're looking at it, let me just show you the difference. So if I go over to this one, this will also be a loop, but notice how this one is negative, which means it's going to be going this direction instead of this direction. So again, I'm looking at going to the left. They have a sum of 5. 1, 2, 3, 4, 5. They have a difference of 1. Again, I'm looking at this for the intercepts, up 2 and down 2. It's going to run through the origin. So I have the exact same looking graph that I did here, but now it's going to the left instead of to the right because of the negative that you see right there. So let me jump to this one. What if they're equal? Well, if they're equal, we get what you call a cardioid. So what do you think of when you think of the word cardioid or the word cardio? Right? You should associate that with a heart. So this takes on somewhat of a heart shape. Not that great of a heart shape, but you'll see why they call it that. I'm still looking at their sum and their difference. This is also a positive cosine, so it is going to go to the right. If I looked at their sum, they have a sum of 6. 1, 2, 3, 4, 5, 6. There's my large radius. Well, what's their difference? Their difference is 0, so there is no small radius, which means this thing will just hit here, and that's it. I'm still going to take a look at my A value to see where the intercepts are. Remember, if it's going to the right, my intercepts are going to be here and here. So on the pi over 2 axis, I'm going to go up 3, I'm going to go down 3, and it's going to look something like this. So our heart shape will go something like this. It's going to bounce off of that guy and go something like this. So that's the cardioid. The cardioid, again, is whenever those are equal. So what's the third type? The third type is if A is greater than B, well, now we get what we call the dent, or sometimes it's called a dimple, or a clam. Got a few different names to it. An apple, I don't know. I've heard a few. I've seen a few in looking some of the things up. But the rules don't change. I still want to look at their sum and their difference. So I'm looking at their sum of 7. So this thing's going to go out 7 to the right because it's a positive cosine graph. But the difference on this one is I am looking at their difference. They have a difference of 1, but instead of going this way like the loop, it goes the other way. So this actually goes away from the origin with their difference. I'm still looking at this for the intercepts. So up 4 and down 4. So, but this guy never hits the origin, right? So it takes on a shape that goes something a little more like this. And then it sort of flattens out right there at that small radius, and then comes back down to look like that. So my drawings are ugly, but this is the cardioid. Kind of looks like a heart. If you draw it better, it might look like a better heart, but that's the main idea. So what kind of symmetry do those have? This is a great question. This is a big AP question. So these guys clearly have polar axis symmetry, right? I can fold my paper on that line, and this half would lay on top of this half. So that's my line of symmetry, pi over 2 symmetry. I'll go through these really quick, but really similar idea. It's just now they're going up and down instead of left and right. So not a whole lot of change otherwise. So if A is less than B, I get the loop. So it's a positive sine graph, so now we're going up, we're going in the upward direction. So their sum, 1, 2, 3, gives me the large radius. Their difference gives me the small radius. It will go through the origin. I still look at the A value for the intercepts, but now my intercepts are over here because it's a sine graph. So my A value is 1, so let's go 1 that way. Let's go 1 that way, and that's the outline of the loop. So with this guy, sine graphs actually start at the origin. So if I draw this properly, I think I'm drawing this properly. Go to the large radius, and back to the origin. And you'll see where all that comes from as far as the order in a later lesson. We're going to look at how would you compare this to a typical sine graph if you were to just graph a normal sine graph from left to right. And you'll see why this starts and ends where it does. Jump over here. If they're equal, we have the cardioid. So they have a sum of 4. This is a negative sine graph, so 1, 2, 3, 4 downward. A sum of 4, their difference is 0, which means it hits at the origin. Sideways 2, both directions. And the sine graphs start at the origin, so I'm looking at this guy. And again, you can see why they call that one a heart. That one's a little better. I'm going to throw this in as a quick reminder. Take a look how you can graph these. If you go to mode and set it to polar mode, go to y equals, type in the function 2 minus 2 sine theta. Once it's in polar mode, your window should match what you're in here. So if I go to my window, I'm going to go from 0 to 360. If I'm in degrees, if I'm in radians, go from 0 to 2 pi. And those numbers should be okay. Knowing what I know about the sum and the difference of A and B, I should get the whole graph on there, so I should be fine. Let's hit graph. This is a little loopier than mine, but you can see we're still hitting all the same key points. So there we go. Alright, and then last one we had The dent or the dimple, again, there's some in their difference. I do recognize now that A is bigger than B, so this is why we get the dent, and it does not hit the origin. It's a positive sine graph. Their sum is 5. 1, 2, 3, 4, 5. They have a difference of 1, but remember, it's not like the loop. I don't go that way, I go away from the origin. I'm going this way. Left and right 3 for the intercepts. 1, 2, 3. 1, 2, 3. And if we draw this guy, I'm terrible at drawing these, but I'm hitting all the key points. Something like that. Okay, so let's talk about this page that you see here. I filled in a lot of these already for you, so just take a look at this and we'll go through it. You can always pause and copy down the key points. So again, for the limacins, this was the breakdown that I went through on the other page, so this is how you'll know what the shape is. Do consider the big, I was calling it the big radius and the little radius. You could refer to it as a maximum and a minimum. That will make more sense in the later lesson when we compare these to just a Cartesian plane graph like x and y, and you'll see where those numbers come from. So feel free to pause that, copy those key points down. This is just a good way of understanding the points on the graph by looking at sort of the main points on the unit circle. So this was just a matter of plugging in. So if I had this, I know from the previous page that it's going to be the dent because A is bigger than B, and so we should know that. The large radius, the max, is vertical because it's a positive sine graph. This is just where those points come from. And you can do this with any question. If you ever get stuck on a graph or they ask you something you're not sure about, plug in some numbers, plug in some values into the angle and see what the radius is, and that will give you a lot of great information about this. It'll tell you if you're increasing or if you're decreasing. It tells you if you're getting closer to the origin or farther from the origin. So a lot of those questions can be answered by plugging in some values into theta and getting those. So these were just the angles that I plugged in to get these radii. I plotted those points, and that's where those key points are coming from on the graph. And so I did the same thing down here. If you missed the lesson and you're watching this for the first time, I always encourage you to kind of go through this, sort of pause the video, try plugging those in, make sure you're coming up with the same values, plot them on the graph. I remember how you plot points like this. I go left 2 and then travel pi over 2. So if I went left 2 and then travel pi over 2, right, I'm getting points like this one. So it's great practice. I encourage you to go through those. This was just a couple of the questions that you could run into based on what we just looked at here. So this one is a great question because this one is now making you think backwards. This one is asking you, what's the equation? And there's a bunch of different correct answers you could get from this. But it just says you got a loop. It tells you that there is polar axis symmetry. So that tells you whether it's sine or cosine, but there's polar axis symmetry. And it tells you you have the max radius of 11. Remember, the max radius comes from adding the two numbers together. So a couple things we took into account here. Because it's polar axis symmetry, I know it's a cosine function. Because the max radius is 11, I need to make sure these numbers add to 11. Their sum gives me the max radius. So I want to make sure they add to 11. Because it's a loop, I know that A is less than B. So there's a lot of ways you could fill all those requirements. You just have to make sure that all of them are taken into consideration. And then you got this one right here. Why does the dent never pass through the pole, right? Never pass through the origin. Remember that sine and cosine graphs, they oscillate between -1 and +1. That's their range. So the most we can get when we look at their sum of their difference, and here's a good way to look at it, right? Because A is greater than B, the minimum radius you can get on this is still bigger than 0, right? So you're never going to get 0, right, when you make that comparison. And so that's why it never passes through the origin, and that's why you get a shape like this. that never passes through the pole. Alright, so that's the end of this one. We'll continue next time.